Following the last sound demo I did of the AC Delco stomp box here, I had a suggestion in the comments to try running this after the cathode follower because of the impedance matching. It might improve the sound, and it does a little bit, probably not as good as you would expect. So I'm going to try something else using another older test harness that I made using a dual-triode. That tends to help out the feel and the response of the tone control in the context of a guitar amp. There's a fundamental flaw in the circuit for using it in a guitar amp, and I'll come back to that at the end. But I also have a third thing I want to try out and show you how I can overcome the limitations of this circuit. Okay, let's get to the sound samples. Okay, while the tubes are getting warmed up, let me walk through the setup here. The guitar signal is coming in to the cathode follower. The output of that is going to the AC Delco. Output from there is going into the universal gain stage to make up any gain lost going through the Tonestack. The output from there is going into the EL84 speaker driver. I'll set these controls at about the 1 o'clock, 1:30 position there. It has a little bit of an effect. It is a little bit better than it was before, I'll grant you that, but it still doesn't have any kind of sparkle that I would expect from having a tone control all the way up. There's no chime or anything like that. I'm going to dig out another test harness and let you guys hear what that sounds like. Okay, so the setup I've got here now, this is a test harness I made years ago. It uses a 12AX7 dual-triode, so I've got gain stage 1 and gain stage 2. The guitar input is coming into the first gain stage. The output of that gain stage is going into my AC Delco Tonestack. The output from there goes into gain stage 2 to make up any gain lost going through the Tonestack. The output from there goes into my cathode follower and then off to the EL84 speaker driver. following stage. What I actually need to do is I need to put something else in between the gain stages and the cathode follower. Alrighty, so I have added in, this is the old Princeton Tonestack, and it's running in between the output of that second gain stage to the input of the cathode follower. It doesn't sound great. The high end does carry through a little bit better, but again, it's not wonderful. Let's try something else. Just for grins, I decided to try something a little unusual. I'm taking everything out of here that I don't need. And this is about as simple as I can get. I'm going guitar gain stage 1 to AC Delco and gain stage 2 directly into the EL84. The results are really better than anything else that I've tried today. Both controls at about the 1 o'clock position. Turn up the volume. So really, in many ways, this is much closer to a Fender Princeton than all of the configurations I've tried in the past. 2 triode gain stages with a volume and tone control in between them, and the second gain stage directly feeds the speaker driver. That right there is about as simple as it gets, and it has had the best uncomplicated sound. All in all, this has been an extremely frustrating set of sound samples to give you because the AC Delco is a great volume and tone control for the purpose that it was designed. It was in a car using a stereo system, a preamp and a power amp and a set of speakers that were designed to work together. And that's really the point to drive home here. Back in the 1930s, when Fletcher and Munson, working at Bell Labs, studied how the human ear works with loudness across a frequency spectrum, they found out that the ear was very sensitive in that 1 kilohertz region, that our hearing was not very good, and we had to really amplify signals in the very low frequencies and the very high frequencies. But by and large, that's what the AC Delco Tonestack was designed to do. It was designed to work in that inverse kind of relationship that as you turn the volume down, it would tend to boost the upper and the lower frequencies so that we could still hear it and have some perceived loudness. That's why we have a loudness-tap. It was an analog solution for the time, and it was the accepted solution for the problem at hand, keeping the listening across the frequency spectrum as balanced as it could be at different listening volumes. Now, as time went on, technology changed, preferences changed, and the whole philosophy about what made a good hi-fi system was all subject to change. The loudness-tap really fell out of favor as an analog solution. Perhaps it wasn't a great idea to try to put it into a guitar amp. I was just trying to get something that approximated or tried to emulate the really good sound that I remember from my velvet memories of commuting around and listening to stuff on the radio. So there are better solutions out there. I don't even think we really need a loudness tap for a guitar amp, because there's easier solutions with treble and bass, like in the James or the Baxandall Tonestacks. And we also have the classic Fender, Marshall, Vox, bass, mid, treble tone controls. And then we have parametric EQs like in the Mesa Boogie. We have a lot of other solutions to change the loudness of the different frequencies across the spectrum. At the end of the day, and at the end of all of this analysis and experimentation, really all I'm after is I want to build a decent guitar amp. So if you're into this kind of experimentation, perhaps to build a guitar amp of your own, do consider subscribing to the channel. I'd like to see you come along. And I'll see you next time when we continue these sonic experiments. Catch you later.